You are to do number 28. This video solves a similar problem, uh, which is number 29. Okay, and this is what the problem says. It says in 1891, Elman B. Stroger patented a phone dialing machine that could connect up to 99 subscribers. How many different two-party calls would such a machine permit? So the very first thing we need to do is understand the problem. And so what we'll do here in order to try to achieve that understanding is sometimes it's easier to start with a simpler problem in order to understand the more difficult problem. And I would say the more simple problem is a situation in which you have two callers, and let's go back to the question, which I'll simply read. It says, how many different two-party calls would such machine make? So obviously you can only make one two-party call when you connect to callers. The question is now, what happens if I now have, say, 3 points of contact, 3 callers? How many two-person calls can be connected? Well, there's these two can be connected, and then these two can be connected. So you could start kind of keeping a tally. Oops, that actually is 3. Keeping a tally of how many two-party calls can be made. Again, I'll just note this is part of understanding the problem. And so if you go back to the problem, we're actually trying to understand what happens when you have 99 of these points and how many potential calls can be, two-party calls can be connected. So let's go one more step in trying to understand the problem, and notice how more complex the problem gets as you add each subsequent number of connection points. So you have these 4 connections, but now you can also start crossing lines. And so if we count here, we have 4, 5, 6. Okay. All right. So I guess the next thing to do is to devise a plan. That's the general problem-solving strategy is you understand the problem, then devise a plan. Now, one plan would be just to continue to follow the pattern, right, and see what happens. But the only trouble with that, I would say, is that these get more and more complex as we start adding these points, right? And so it becomes a much more challenging problem. So we have the 5 points around, and then we have let's follow the star, 5, 6, 7, 8, 9, 10. So now we're at 10. So you can imagine how this thing might be growing. Now, if we want 99 contact points, we'd be in a bit of trouble, right? So you may, at this point, start thinking of whether we can do some more inductive reasoning rather than just counting and looking at the pattern. So I would say devising a plan is to think more of in terms of inductive reasoning, which means look at the pattern and see if you can make some educated guesses about what might happen at the 99 point. Now, 99 is still pretty far down the line, but I think one thing you might notice, and this is not necessarily automatic, but you may notice that the difference between these is 2. The difference between these is 3. The difference between these is 4. And so what I would recommend here is maybe just to go, because you could start seeing that each time you're adding the next integer up, right? So the question would be, well, what happens if does adding 5 more actually get me to the next one? Again, there's some challenge here with the drawing because it's getting you're getting more points. So there's these 1, 2, 3, 4, 5, 6 points of contact. Now we suspect that there should be 15 if the pattern follows. So then 1, 2, 3, 4, 5, 6, 7, 8. Okay, so if you count them, you're gonna find out, yes, there's 15. So there is something to the pattern. The question is, well, that's fine, but how do I get all the way to 99, right? Because we have to carry out some kind of plan, carry out the plan. And I would say in a situation like this, I would recommend that you, if you have some skills, for example, with Excel, that's how you carry out the plan. Okay, so let's go ahead and take a look at an Excel spreadsheet. I'm actually using Google spreadsheet. And what I want to do is first create a list of integers. Okay, and this is going to serve 2 purposes actually. It's going to tell me how many potential callers there are. And this is analogous to the points on the drawings that I showed you. So if there were 2 dots, there was 1 call, there could be 3 dots, and so on, right? But I don't want to sit here and write down the whole list all the way up to 99. So I'm just going to add 1 to the previous one, and it's going to allow me to drag this down, and I can go as far as I need to, which we're interested in 99 calls. So we'll go down to 99. And then to get the number of 2-person calls, we remember the picture. So if there were 2 people, there could be 1 2-person call. If there were 3 people, you would have 3 2-person calls. And then rather than using the pictures entirely, although we should reference them, we're gonna need a formula. And the way the formula works, and this is back to inductive reasoning, you take the previous value, and what you do to it is you add the previous integer value, which is this one. And just to verify it, it does match. And if I let's just drag a few of these down. Now we're getting 10, which is 10 and 15, which is in fact what we got. Now the formula, it could be a little confusing. We took the 6 value, which is in cell B4, and we added A4 to it. So it's B4 plus A4. And then this one's going to be B5 plus A5. And this is B6 to A6. And so on. So now I can just drag this all the way down and get my answer. So if you have 99 callers, you can have, according to this, 4,851 potential two-way calls. Let's go with a more simple way of checking back. And what I would recommend for us at this level is maybe just to verify one of the other values on the list. Maybe 8 won't be so hard to draw. It should come out to 28 connections. So let's see if we can verify that. And I think that's an acceptable way to look back at this level. So let's go ahead and do that. All right, so let me go ahead and share. The easiest thing here is just to go around the edge and make 2-person connections with these 8 dots or 8 people. And so those are the easiest ones to do. Now, let's start with this one. I'll just kind of darken it just to help me keep track of where I am. So that was 8, and here's 9, 10, 11, 12, 13. So that's 13. And then I'm gonna go to this one, 14, 15, whoops, 16, 17, 18. No, that's already done. 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, and 28. And then it's just going to be up to you to make sure that you've connected all the points. But I think that's a fair way to do looking back on this particular problem. It matches the list we made on the spreadsheet. And so this is an example of how you might solve these sometimes challenging problems.